Welcome back to the Gemini Exploration series. Today we'll be blazing through the code. So last time we talked about Google AI Studio, where we were able to look at the prompts and various things that are going on, various options that we have available here. We went through some prompts as well, some sample prompts, and we ended with just different prompts for you to try out. Today we'll get deeper into how you can start using all of the things that you learned here into your own code. So one of the best features around on Google AI Studio is the ability to get code on whatever you are working on. So you can see this, I'm looking at a Python sample code where it will give me the complete code that I'm using with all the different parameters that I was using it on, along with the model that I was using it, any other generation config. So this is the complete generation config available here. And if I had a chat history, it would include that in here as well. If I had a system instruction, it would include that in here as well. So this gives you a complete code that you can start copy pasting and start running it today. Of course, it allows you to do the same thing in JavaScript, Android, and Swift as well. So yeah, you can get started right from here. We will dig deeper using Python. So I've created this. I found this cookbook on Google Gemini repo, and using that, some examples from there. This is really well done and thorough repo in here, which has examples and quick starts. I've taken some examples from there and created this Colab notebook in which we'll go through multiple topics. So we'll get the key, set up the SDK, then we'll go through some tokenization, we'll do some prompting, and then finally we'll end with the JSON mode on how you can get the output for JSON. As developers, that's the preferred way, at least for me, to deal with my data. So how do you get your key? So to get the key, you navigate to this aistudio.google.com app/API key. So let's go there. So in here, if you do not have a project, you can create with an API key. Since I already have a project, it's using that project. And here are the two keys that I've created. It shows on which dates, and I'm on a paid plan. So it shows me that I'm on a paid plan. I can go to the billing. Here it shows me a call request that I can use, and by passing in my API key, I'll get the response as well. So I take the API key from there and copied it, and then on Colab you can add it to your secret section. So in here, this is our secret section, and I'm give the access to this API key by toggling this on. I already ran this repo. I think, one second, I just want to see. Yeah, so this whole repo was already ran by me. So all of these responses are already pre-generated. So we'll just go through those. Okay, so here's the last four of the API key that I had, and you can see it here as well. Those are the same API key, same last four values. As we go through this, we just got the key, we added it to the Colab, and Colab provides an easy way to access the user data that you have saved in here in the secrets, and we got this using Google API key. That was our key from there, and I only printed last four. I don't want to share my whole key. Okay, so that sets up, we got the secrets that allows us to access this Google AI Studio, everything that we were doing here through API. It also allows you to measure how many API requests you are making and any kind of paid billing issues that you have. Those will all be available through API. Those will all be connected to your API key, so you can go back and look at those details. Okay, so dig deeper. So we set up the SDK in here. We ran this, and the package here is Google Generative AI. That's the package. There are packages available for other languages as well. These are the different languages that they are supporting right now. We download the package. This -u allows you to update it as well, and -q allows us to do this silently in the background rather than printing a big list of details in here. Then we import our package and we configure it using the secret that we have saved, which is Google API key. So with this, I don't have to pass in my API key every time. I just configure the Gen AI package in here to use the new API key that I have saved in my secrets. Then this is a really easy way to see what different models are available. You probably need to know what different models are available, but you can see the capabilities of those models. So in this example, I have input and output token limits based upon each model name. So we have the model name on the left, the input token limit. Gemini has 1 million input token limit and 8,000 plus output token limit. but ultra in this case is smaller, 1.0, because that's 1.0, this is 1.5. Smaller token input and output as well. And similarly, Pro, it has a very high input, but output is still the same as Flash, 8192. So we talked about tokens last time, but let's dig deeper into how you can start using those and start looking at those for these different use cases. And in this example, we'll go with text, chat, images, audio, and video. And of course, we will see how system instructions, tools, and safety settings affect our token count. Uh, More often, you'll be built using tokens, the number of tokens that you are passing through the system, inputs and outputs both. So it's good to know at least what you're doing and how many tokens it's going to cost. So I took a simple brief description of Gemini constellation, and it talks about the Pollux, which is the brightest star in the Gemini constellation, and it's closest of its kind to Earth. So we pass it in, and using Gemini 1.5 Flash, we count the number of tokens for this input. Note that we haven't sent this to Google yet. We just asked it to generate token count. This is not being asked to generate anything else in here. We are just counting the tokens. So when we generate the response text, this is the complete response text out here. You can see there's a property available in the response, which is usage metadata, which has the prompt token. So this was our prompt text, which is 25 tokens. In here, it says 26 because it adds one extra token, which will be used as the impetus for saying the model to say go. This is the point you start generating. So that's why it's 26. And then total candidate token count is 213. So candidate is this output that it generated. And then total token count is sum of both of these, 239 in here. So remember this, that's total token count matters because it depends on what you're trying to generate, but also your candidate token count can't be more than this available here, what it's trying to generate. So these will be affected by candidate token counts. If your candidate total count is bigger than this, the output won't work probably. It might break, it might throw an error. Okay, so we saw this for normal text response, but what happens if I'm doing chat? And in chat, one of the important things is you want to keep and preserve the whole history. So in this example, we have a history by a user who's saying, hi, my name is George, and then the model goes, hi, George. So this is the input, and we can see the whole token count for the chat history. There's 12 token counts in here. If you wanted to see, take a look at the complete chat data model in here. So it shows you that the model that it's using in the background is Gemini 1.5 Flash. There's no safety settings set up in here. And you can see in the history of the contents in here, there's both of the user text as well as the model text in here available. Now we can count if we were to add another input to this chat, another user input to this chat, what would be the total token count? So we wrote this, are you the George from Seinfeld? That's a question in here, and we just count the tokens. So we get the token count is now 18. From 12, we went to 18. But just know that it did not pass the text to the chat. It's not available in the history. It did not get added here. We just did the calculation. So that's all text. We will go now into images. On images, we will just download the images. So this is an instrument image, an organ image, and we download this image, and then we try to just to show you here, and then we are passing it again to the model and asking, tell me about this instrument, and we pass in the organ as the image, which is this image right here that we opened the image and pass it along as a input to the count token function. So that we see the total token count has increased. This text, you would not expect the text to just have 263 tokens, but including the image now, we have a large number of tokens in here. One of the things about Gemini is it encapsulate or does a token conversion from an image to token based upon a fixed set length. So this input image as well in here, we took another image, and we asked it to again generate token size for those, and we see count token for both of those is actually 258, even though the dimensions of the images are very different. So the whole image is compressed into 258 tokens. So keep this in mind when you're trying to do a very large image and you're trying to use that to do Q&A or any kind of task, it might not work as well because we have tried to compress all the information that is in that image into a much smaller section in here, much smaller token count. So you might want to do more smaller multiple images to get the better result. Okay, moving on to audio and video. Audio and video are tokenized at a fixed rate of tokens per minute. So again, similar thing where it's based upon the information density. If there's a lot of things going on in one subsegment of audio, in 1 minute of audio, versus it's quiet in the second minute, the number of token count does not decrease. It's going to be the exactly same number of token counts per minute. But you might lose the amount of information that is available between when you recorded just a voice versus when you are recording voice with a lot of background noise. So in this case, we generated the token count is 83,000 tokens in here. Okay, so let's see how system instructions modify the token count in here. So this is our input text. We see that the total count is 25. And when we add some system instructions to say talk like a pirate, it increases the total token count to 30. When you add any functions, so this is system instruction. When you add system instruction, it increases that total count. When you add functions, it also increases the system count or the token count in here. Then if you add safety settings in here, safety settings actually do not increase the token count. So this is very well done job from Google side. And I think it might be doing where rather than passing the whole value as a token inside to the model, this might be an external thing that's happening after the response has been generated and before the response is sent to you. This is secondary processing on top of the generated response. So that's why it's not part of the token count, but I'm not sure. I don't know exactly how they're doing this. I don't know exactly how they're doing the safety classification and blocking of the content, but what I can say is it's definitely not being counted in the total token count. Okay. Now we dig deeper into prompting. So now that we know the number of tokens that we'll be consuming, we can more confidently go into the conversation and actually start doing the generation part of it. So we ask our model to generate the content in this case tell me about George from Seinfeld. So it generates the whole summary in here, and this is in markdown format. That's why you see these two asterisks, which will make this bold text. And you can see these slashes as well. So yeah, it does a pretty good job about George Costanza because probably model has learned a bit about George from the openly available data as well. As always, you can see the response in here. Response has candidates in here, parts, and which has the text. There's complete text in here. You can also see that what was the reason that model stopped running. And in this case, it's stop, which is finally model was done generating the response and it stopped. However, if you had safety reading set up and if the question or the generation prompt was something that did not pass those safety settings, you will see a finish reason here specific to those safety reasons. Then of course you can see the usage metadata in here on the prompt token count, candidate, which is the output generated, and the total token count in here. Moving on to audio. So now you can also update your audios in here. So I have a sample file in here, a WAV file that I asked it to listen to the file and then provide a brief summary. So it listens to the file. It's a very small file. So in this case, remember, we are uploading the file. The package provides an API to upload the file directly. In this case, we uploaded the file and then we are passing the file directly into the input and then asking the model to generate or do a brief summary. So here's the brief summary of what the audio itself has. And again, there was no reason to stop the model early. We see that the prompt token count is actually high in this case because we passed in the whole audio in here. And the output response was fairly simple in text format only. Finally, to JSON mode, what most of the developers worry about or care about in this case. So we come in here, we just add some extra packages in here, which will allow us to look at the model or look at the responses properly. And we ask the model in here, this is the most interesting part of it, you can set the response MIME type to application JSON. This allows you to return the output in JSON. This is just telling the model in a very simple format. that output should be in JSON. Now that JSON output itself might be using random keys, and if you don't want that, which you probably don't want that to happen, you can specify your own schema. So in this case, we specify an object called entity, which has entity type and value, both of the values as string, and we provided it a raw text, and I'm asking the model to find different entities from the provided text and return them in this following schema. And I provided it a data type entity, and then I'm giving it that the output should be a list of entities in here. I pass the response in, and it generates the whole response. Of course, all the different entity types are present in here: location, season, and then of course another location, another season. This is a example of this text is contains different activities that you can do in New York in different weathers and different seasons. So another way to say this prompt part, rather than doing all these changes within the prompt, you can define these data structures outside of the prompt itself, and then you can pass those as the response schema directly from a response schema type in here. So you don't have to put those into your prompt, and you can put it directly into your code. So that way, this can be used by the rest of your code somewhere else as well. And that will allow you to reuse this and not worry about coming in and changing the prompt every time. And of course, it uses those that response schema to generate the same output again. So yeah, these are all the things that we went through right now, where we set up our key, we got our key to make sure that we can make the API request directly to the models in the backend. We got the key from Google AI Studio, and then we set up our SDK, we tokenized, we learned about how you can tokenize not only text, but video and audio as well. I didn't show an example of video, but works the same way, where you just upload the video file and you can see the token count for it. We also did some prompting on text, some on audio as well. And then we finally got the output in different JSON modes, and in a way which allows you to keep your code working and extensible, and so that you don't have to come into the model and every time make some changes. So yeah, that was blazing through today on our Gemini explorations part. Next time we'll dig deeper into a few topics rather than just blazing through. Nice. Hopefully you enjoyed this. Thank you so much, and see you next time.